Hi everyone, this is an example of a problem building a redox table. We have a list of 4 reactions provided to us, and we're also told whether they're spontaneous or not. What we're going to do is apply our knowledge of spontaneity rules in order to order these chemicals, and then we're going to construct a table of reduction half reactions from that information. Our first step is to identify the oxidizing agent and the reducing agent. We have beryllium solid becoming beryllium ions. The neutral atom became positively charged by losing electrons, by getting oxidized. The beryllium solid here is the reducing agent. The cadmium ions, these Cd2+ cadmium ions, became solid cadmium atoms. If they were positively charged, they became neutral by gaining electrons, by getting reduced. The cadmium ions here are the oxidizing agent. The question tells me that this is a spontaneous reaction. If the oxidizing agent is higher than the reducing agent, we have a spontaneous reaction. This first equation is telling me that the cadmium is going to be higher than the beryllium. It's spontaneous, the OA is above the RA. I'm going to make a note without any charges, without any labels, just to say that the cadmium is higher than the beryllium. Cadmium is above the beryllium. And I move on to the next reaction. This time we have cadmium solid becoming cadmium ions. The solid becoming positively charged, losing electrons. It was the reducing agent. I have hydrogen ions becoming hydrogen gas. The positive ion becoming neutral by gaining electrons, by getting reduced. It's the oxidizing agent. Again, we're told that this is a spontaneous reaction. If it's spontaneous, the OA is higher than the RA. This second equation is telling me that hydrogen is above cadmium. The first reaction said cadmium is above beryllium, but the second reaction goes further to say that hydrogen is above cadmium. So what I'm going to do is just put H up here. I'm slowly working out the order. The third reaction, calcium ions becomes calcium solid. The positive ions get reduced to become the metal. So the calcium ions here are the oxidizing agent. The beryllium was neutral, become positive by losing electrons. It's the reducing agent. This time, the question is letting me know that this is a non-spontaneous reaction. If it's non-spontaneous, the OA is below the RA. So this is saying that calcium is below beryllium. I'm starting to work out the order, and this third reaction says the calcium is below the beryllium. The OA is below the RA in a non-spontaneous reaction. The process continues. Copper solid becoming copper 1+. The neutral atom becomes positively charged by losing electrons, by being oxidized. The copper over here is the reducing agent. These hydrogen ions becoming hydrogen gas by gaining electrons, by being reduced, it's the oxidizing agent. Again, we're told that it's non-spontaneous. Non-spontaneous means the OA is below the RA. I already have hydrogen here in my list, and this is saying that the reducing agent copper solid is higher than the oxidizing agent because it's non-spontaneous. So here, what I need to do is put the copper, above. So this is the copper up there. I took the reactions one at a time by labeling the OA and RA and applying just those two basic spontaneity rules in order to come up with some type of order. I have copper at the top, hydrogen, cadmium, beryllium, and at the bottom, calcium. Once I have the order, I need to turn these 5 chemicals. I have to construct reduction half reactions for them. That table always starts with the oxidizing agent for the chemical. So that means it would be the CD2+, the hydrogen ions, the calcium ions, the hydrogen again. Because my copper is here at the top, I want to make sure that I use the oxidizing agent version of the copper. For metals, that's always the ionic form. So here I have copper 1+, hydrogen positive, cadmium 2+, beryllium 2+, calcium 2+. The charges were I could find them all here in these reactions, even for the copper. Now I'm writing reduction half reactions. They're all going to gain electrons. They're going to gain the number of electrons that corresponds to the charge. Something special is going to happen with the hydrogen, so let's take them one at a time. Copper 1+ gains an electron to make copper solid. These hydrogen ions, they're going to gain electrons as well, but it's going to be a little bit more particular. Because they're going to make hydrogen gas, we need to balance that. It's H2, so that becomes a 2 right there. Each hydrogen is going to gain 1 electron, but there's 2 of them, so it's going to take 2 electrons this time. The cadmium is 2 positive. It gains 2 electrons to become cadmium solid. The beryllium and the calcium, the same. Plus 2 electrons, makes solid beryllium. Calcium gains 2 electrons to make solid calcium. What we've done is we've taken the reactions provided to us, used our spontaneity rules to put those chemicals in order. And then we've turned it into a table of reduction half reactions, where the strongest oxidizing agent is at the top left, and they're decreasing in strength. So we have the weakest oxidizing agent at the bottom. On the other side, it's the other way around. The strongest reducing agent here is the calcium solid in the bottom right-hand corner. And this time they're getting weaker and weaker as we go up. So out of these 5, the weakest reducing agent is the copper solid. When we are asked to build a redox table, we really need to take our time, but it is a matter of applying spontaneity rules and what we know about the construction of the redox table to put things in order. And I hope that helps.